Hello, my name is Cody Abrupta, and I'm a licensed professional civil engineer working for the Maine Department of Environmental Protection. I'm a member of the Stormwater Engineering team, which is part of the Land Bureau. Today we're going to be talking about stormwater wet ponds. Here's an overview of how the presentation will go. We'll first talk about the function and design of stormwater wet ponds. We'll then discuss ponds in series. After that, we'll talk about submissions that need to meet Chapter 500 standards. Then we'll briefly touch on the construction process. We'll spend a little bit of time on inspection and maintenance procedures, and then we'll talk about the 5-year recertification. So wet pond function. Before we talk about the function and design of wet ponds, we should understand that sometimes these wet ponds are referred to as retention basins, stormwater ponds, retention ponds. Basically, the idea is that this is a stormwater control measure that's supposed to have water in it between storm events. There's what's called a permanent pool that remains in this control measure. And so it's not intended to go dry between rain events like a detention basin or a vegetated soil filter. So there's always going to be some amount of water in these ponds. Now that's important because it helps prevent sediment from being uplifted back into the stormwater during a rain event, and it's also important for maintaining certain microbial activities and populations. Now, how do wet ponds function? Well, this is how they work. The primary water quality treatment mechanism for wet ponds is settlement. So as water comes in, the heavier particles will settle out in the forebay, just like most pre-treatment measures. As the storm water flows from the forebay or from the inlet across the pond to the outlet structure, additional settlement is occurring. So particles are settling out, falling to the bottom of the pond, and being stored there. Now, the reason why stormwater ponds tend to be longer, linear in nature, later on we'll talk about the 3-to-1 length to width ratio. But the reason why they tend to be longer in that form is because it increases the residence time, or basically the amount of time that it takes for stormwater to flow from the inflow pipe to the outlet structure. An increase in residence time increases the amount of settling that occurs, which helps improve the quality treatment. Now, wet ponds are also providing some nutrient removal. Nutrients like phosphorus and nitrogen attach themselves to sediment particles. And so as the sediments settle out of the stormwater, it's also effectively removing those nutrients from the stormwater. Now, in wet ponds, there's also microbial activity that help break down some of the nutrients. In a lot of cases, wet ponds have a vegetated buffer around them, and that vegetation is able to remove some of the nutrients from the stormwater. And a recent innovation to stormwater management, floating treatment wetlands or floating treatment wetland islands are also able to effectively remove some of the nutrients. Basically what those are is it's a floating structure, a floating plot of vegetation that's allowed to exist in that permanent pool. And it can remove those nutrients as well as increase the residence time. It's a recent innovation. We're not going to talk a lot about it in this presentation, but it's something that's growing in popularity. Now, besides sediment settlement and nutrient removal, we also have storage. Wet ponds tend to be a larger stormwater control measure, and because they're a larger control measure, they can provide a lot of volume storage, so we can help reduce the stormwater quantity that's running off of a site by storing it above the permanent pool. We'll talk a little bit more about that during the design phase of the wet pond, but that additional storage above the permanent pool, it allows water to, basically pond in this control measure and then be slowly released over time through the outlet structures, effectively providing some flooding prevention and meeting flooding standards. And then finally, we'll talk a little bit about temperature regulation. So again, when you've got rainfall hitting hot impervious surfaces like asphalt, parking lots, etc., it heats up that water. And we don't want that warmer stormwater running off into our water bodies because it could negatively impact uh, aquatic ecosystems. And so when that stormwater enters the wet pond, the ambient temperature of the water helps cool that stormwater. The amount of time it takes for that stormwater to flow across the pond helps provide some cooling. And then specifically the underdrained gravel outlet structure provides additional cooling because it's basically underground, and underground is cooler than the surrounding air temperature. And so it provides additional cooling as it's leaving the system. So wet ponds can also serve as a temperature regulator to prevent warmer stormwater from entering our water bodies. If you look at the graphics at the bottom of the presentation, you can see some of the primary components of the wet pond. We'll talk a little bit more about them in the next slide, but briefly, in the at the left side of the structure in both of these diagrams, you've got your inlet. Sometimes it's a pipe, sometimes it's a channel or a ditch or something like that. You've got your forebay. Almost all wet ponds will have a forebay of some type serving as pre-treatment to help control sediment and floatables, debris, etc. Sometimes there's a stone level spreader, sometimes there's a berm, but after you've got your forebay, then you've got the rest of your permanent pool for your pond. There's what's called a pond bench that surrounds the permanent pool. This is basically a safety bench to prevent people from falling into the pool and not having a way to get out. And that safety bench also helps increase the storage volume. Sometimes there's some plantings or some vegetation around the pond in this area. And then at the end, you've got an outlet structure. Now, in some cases, we utilize an underdrained gravel outlet structure or a gravel bench. We'll show you a detail in the next slide. Oftentimes, there's an additional outlet structure, so some type of concrete structure that has a trash rack, grates, and additional openings to help control flow from larger, more intense storm events. So like the 2-year, 10-year, 25-year storm events, this outlet structure would help control that flow and release it at different rates. These wet ponds also have an emergency spillway. So in the event that the outlet structure is clogged, the gravel bench is clogged, or if you have an incredibly intense rain event, the emergency spillway is there to help control that stormwater overflow without, destroying the pond or, we want to basically control those larger flow events. And so there's an emergency spillway associated with these wet ponds, especially since that they are designed often to hold a lot of water. And so we want to make sure that we have safe ways for that water to leave the system in the event that there are clogs or in the event that there's an incredibly intense event. And then finally, at the very end of the structure is the outfall area. So it's where the underdrained gravel outlet drains to, or where the outlet structure drains to. That outfall area is often stabilized with riprap, plunge pool. Sometimes there's a level spreader associated with it. But that's the last component from these plan views of the stormwater wet pond. Getting a little bit more into the wet pond design, so per the Chapter 500 stormwater standards, these wet ponds need to be designed to detain runoff volume equal to 1 inch of the subcatchment impervious area. So your subcatchment impervious area, you multiply that by 1 inch, and then you add 0.4 inches times the landscaped area. And that is meant to be stored, right? That design, that detention volume is meant to be stored above the wet pond's permanent pool. This is known as the CPV, the channel protection volume. If you're in a river in a stream watershed, that channel protection volume, so the 1 inch times the impervious area, 0.4 inches times the landscaped area, that channel protection volume is required to drain between 24 and 48 hours via an underdrained gravel outlet. And if you're looking for a detail for that under drain gravel outlet, it's the detail on the bottom right of this slide, the bench detail. Now, below that permanent pool elevation, or basically that permanent pool elevation, the way that we size that is you take 2 inches times the subcatchment impervious area plus 0.8 inches times the subcatchment non-impervious area, the landscaped area, whatever it is. And that's how you determine your PPE, permanent pool elevation, how much water is staying in the system between storm events that is not draining from the system. You also need a mean depth of at least 3 feet and a minimum of a 3-to-1 length to width ratio. So we want this pond to be longer than it is wide because we want to, like I mentioned earlier, increase the residence time, increase the time it takes from stormwater to enter the system and then travel through the pool to leave the system. The bottom left image shows a cross-section of a typical wet pond. Again, we mentioned earlier, you've got all the way to the left side, you've got your inflow pipe with the sediment forebay. Sometimes there's a riprap or a level spreader that enters the rest of the pond. You've got your pond bench level. So the bench level is where water, if it gets higher than that, it's going to enter the gravel bench. It's going to enter that underdrain and leave the pond. You've got additional storage on top of it. So if you look at the image on the left, the cross section, where you see the dashed line with the little triangle and the extra lines underneath it, that's supposed to symbolize water level. So during rain events, water level is stored on top of that permanent pool elevation. That's your channel protection volume. This cross section also shows the outlet structure. It shows the emergency spillway. And again, one of the important features to point out here is the anti-seep collars. These are basically to help prevent seepage from the stormwater pond, and we don't want that seepage to undermine the berm or the embankment of the structure because that could actually lead to a failure and then is basically like a dam failure. It's not good. So we put in anti-seep collars around the liner or around the clay core or whatever it is to help prevent seepage from occurring because we don't want this water that's in the pond to actually drain through other means. We want that pond to be impervious and retain that water. The detail on the right side shows your gravel underdrained bench detail. So again, basically how it works is you've got a bench, which is just a flat area along the side of the pond, along the side of the stormwater pond. And you've got gravel filled in. At the bottom of that gravel section, you've got a perforated underdrain. Now that size can vary sometimes, but that perforated underdrain is what collects that stormwater and takes it either out to the outfall area or it connects to the actual outlet structure, which then drains to the outfall area. So here's a detail of what that bench would look like. Now both of these details or both of these sections are taken directly from the Best Management Practices Technical Design Manual, which is volume 3 of the Stormwater Best Management Practices Manual. Talking a little bit about ponds in series. So Chapter 500 standards allow for some reductions if you're using ponds in series. Now the reason why you would do that is because ponds in series tend to have improved nutrient removal, improved sediment settlement. They basically provide better water quality treatment. If you look at the 2 pictures below, these are not pictures in Maine, unfortunately. I didn't have a picture of those to put into this slide, but they do show some ponds in series. And so if a permanent pool volume is relatively evenly distributed between 2 wet ponds, so you've got 2 ponds and the permanent pool volume is distributed pretty evenly, plus or minus 25%, the required permanent pool volume can be reduced by 20%. So you can actually reduce your permanent pool volume, your total permanent pool volume, if you're distributing it between 2 ponds. Now, if you've got 3 wet ponds in series, assuming that you've got a relatively evenly distributed permanent pool volume between the 3 ponds, the required permanent pool volume can be reduced by 40%. So you're getting reductions in permanent pool volume if you're putting ponds in series. And ponds in series tend to be one of the best phosphorus reduction mechanisms that we have. So that's how it's explained in Chapter 500. Now, for projects that need to meet Chapter 500 standards, this is your stormwater projects and your site law submissions. Submissions that have a wet pond proposed as stormwater treatment need to include some additional details. So submissions need to include a topographic plan view of the pond. You need a cross-section of the embankment, specifically one that shows peak storage depths. So the channel protection volume, what level, what elevation is that going to get to? The 2-year, 10-year, 25-year storm events, what elevations are those getting to relative to the embankment, relative to the outlet structures? You also need to provide a cross-section and a profile of the overflow spillway. You also need your soil test data because, again, it's a stormwater control measure. You need your soil test pits, so we need to see that profile and that data. You need to provide a cross-section of the gravel underdrain that shows the thickness and gradation of gravel drainage fill and a diameter of the perforated underdrain pipe. And then finally, you also need to include a maintenance plan, which we'll be discussing a little bit later. So this is what's required per the stormwater and site law submissions section of Chapter 500. I encourage you to go back and read that. So going through the construction process, we start with site preparation, which includes your clearing, establishing perimeter erosion controls and sedimentation controls. After you've done that, then the excavation and grading occurs. Now, stormwater ponds tend to be larger stormwater control measures, and because you've got a permanent pool elevation, they tend to be a little bit deeper than some of our other stormwater control measures. Because of this, groundwater is sometimes a concern. So if there is groundwater, high levels of groundwater, you may need a dewatering plan. Be sure to check the details provided by the engineer. But that's excavation and grading. Once excavation and grading occurs, you're also going to install your liner and the anti-seep measures, as well as establish the embankment. So sometimes these liners are poly, plastic, impermeable membrane liners. Sometimes this is a compacted clay liner. Refer to the details provided by the engineer. And then again, like I mentioned earlier, those anti-seep measures are basically to help prevent water from leaving the pond in any other way that's not intentional to the design. We don't want to undermine the embankments, especially if these ponds are going to be storing large volumes of water. We don't want any failures occurring. So we install the liner, anti-seep measures, and we establish that embankment, which, again, may need to be compacted. See the Chapter 500 standards for more details and check the BMP manual. At around the same time, the emergency spillway is installed, and the outlet structure and gravel underdrain are installed. Once those features are installed, it's also important to stabilize the outfall area, so where the stormwater eventually ends up after it leaves the system. It's also important to establish the embankment vegetation, so we want these embankments to be stabilized. We don't want them to erode during rain events, so that includes loaming and seeding, planting, mulching, whatever you need to do to establish those embankments. And then once the wet pond is fully constructed, then you get into your post-construction inspection and maintenance practices. So a maintenance plan for stormwater wet ponds. This comes from Chapter 500. An inspection and maintenance plan should be provided for stormwater wet ponds that includes inspection and maintenance for pond embankments, the outlet structure, the gravel trench or the gravel underdrain system, if that's applicable, and the emergency spillway. Any maintenance plan also needs to include provisions for sediment removal and disposal and control of woody vegetation on pond embankments. Again, we don't want trees and woody vegetation to be on those embankments because, again, if that tree falls over or it's toppled, it can actually pull out some of that embankment, and it could lead to a failure, which is a hazard, a safety hazard. So that's why we include that provision. As far as inspection of wet ponds are concerned, so the very bottom table, this comes directly from the BMP manual, Volume 3, the Technical Design Manual. I'm going to read through some of the details, and then I'm going to go through how a typical inspection of a wet pond might occur. So again, wet ponds, and this also refers to detention basins as well, inspected annually in the fall and after heavy rain events. Some of the important details are inspecting the embankments for settlement, slope erosion, piping, slumping. Again, we want to make sure that those embankments are in good condition and they're not eroding. Sometimes we mow the embankment to control that woody vegetation. That may only occur once or twice a year. But again, we want to control the woody vegetation around the pond. Inspect the outlet structure for broken seals, obstructed orifices, and plugged trash racks over time. Depending on the subcatchment drainage areas of these ponds, they can trash or other debris can clog those outlet structures. We want to make sure that that's getting removed so that the wet pond can function as designed. Removing and disposing of sediments and debris within the control structure. So if anything gets into the outlet structure or into that gravel pipe outlet that we don't want there, we should be removing that and disposing of it properly. Repairing any damage to trash racks or debris guards. Again, in higher flow events, any type of larger debris could potentially damage those trash racks. We want to make sure that they're in good functioning condition. Replacing any dislodged stone in the riprap spillways. So this riprap spillway could include the emergency spillway, or it could even be in the outfall area of the wet pond. We want to make sure that everything is in good working order. And then finally, remove and dispose of accumulated sediments within the impoundment and the forebay. So again, that forebay is providing some additional sediment removal. That needs to be cleaned out, just like other forebays in other stormwater control measures. Now, if I'm an inspector on a property that has a wet pond, after I inspect the drainage area that's draining to it, of course, you would want to look at the catch basins, the pipe systems, the drainage channels that flow to the wet pond first. But once you get to the wet pond, you would want to inspect the inflow pipe or the inlet area, whether that's a pipe or a drainage channel. You want to inspect that to make sure that it's not eroding heavily, that it's in good working condition. That's also going to typically include the sediment forebay. If you see a lot of sediment accumulation in that forebay, you're going to want to recommend that gets removed. You want to make sure that there's no woody vegetation growing in that riprap area. Once you've done that, the permanent pool, you want to make sure that the surrounding embankments, like I mentioned, are clear of woody debris. You want to check for any undermining, make sure that the embankments are in good working condition. The outlet structure and the underdrained gravel bench, that's going to be where you're going to probably spend the most time during your inspection, making sure that everything looks good. The outlet structure, trash rack, inside the outlet structure, if you can access it. Oftentimes these outlet structures are close to the embankment or close to the edge of the wet pond. In this diagram, in this plan view, it kind of shows the outlet structure out in the middle of the pond. That's actually not as common. Typically these are accessible from the side of the pond, but if they aren't, you may want a means of getting to that outlet structure, whether you've got a kayak or canoe or some type of float to get out there to take a look inside of it, because it's important to check the inside of that outlet structure and check the outside of it. You're going to inspect the underdrained gravel bench, make sure that it's not completely clogged with vegetation or sediment, debris, etc. You may want to take a look at the emergency spillway to make sure that there's no woody debris growing there, make sure that everything is in working order, that all the stone is where it needs to be. And then you're also going to be sure to check the outfall area to make sure that water isn't draining in a uncontrolled way You want to make sure it's stabilized. One of the things that you may need to do, depending on how old the stormwater pond is, the wet pond is, you may actually want to check the sediment deposition at the bottom of the pond. Now, one of the ways that I've done this in the past is actually getting in a kayak or a canoe with a, with a measuring rod, some type of long measuring rod. Sometimes this can be a survey stick or something like that. And you go to the middle of your permanent pool and you put it into the pool until you can hit the bottom. Oftentimes that sediment at the bottom is going to be that soft, mucky consistency, and you push it down until it gets to the very bottom, until you get to that bottom harder surface. And that can help you determine how much sediment is actually accumulated at the bottom of the pool. Because these wet ponds, again, over time, they're accumulating that sediment, and sediment accumulation can actually impact the function of the pool. It can reduce the flooding storage capacity. And so if you notice that during dry events, the pool elevation, the permanent pool elevation, is actually pretty high, higher than you would anticipate it to be, that might be an indicator that there is a lot of sediment accumulation. And you may need to measure that sediment accumulation. If it's accumulated significantly, you may need to dredge the pond and clear out that sediment or vacuum it out. There are a couple of different ways to go about doing that, but that's something to consider. Would I measure the sediment at every inspection, especially like if you're doing quarterly inspections? Absolutely not. It's probably unnecessary to do that, but maybe once annually or every few years, it may be important to measure that sediment level in the middle of the pool, in the middle of the wet pond, to determine what the levels are. So that may be something to consider as well. And then finally, as far as inspection maintenance, 5-year recertification go, any type of inspection and maintenance activities should be kept in a log or in a report that summarizes what the activities were. So what the inspection was, the maintenance actions or activities, any corrective action that was taken, that should be logged and documented. For the 5-year recertification, again, you're identifying and repairing any erosion problems. You're inspecting and repairing the stormwater control system, making sure that it's working as it was designed. It's important to certify erosion and stormwater maintenance plan that was created for the site or created for the wet pond is actually being followed and implemented. And then finally, for recertification, for 5-year recertification documents, to submit your recertification form and the photo report, you can send it directly to that email address that's listed in the slide, recert-dep@maine.gov. For more information, visit that link at the bottom. It's got copies of the recertification form and some important details that you may want to review before doing your 5-year recertification. Here's my contact information. I hope that this presentation was helpful and gave you a good understanding of stormwater wet ponds, how they function, and some of the common and important inspection and maintenance activities that are associated with them. For more information, you can visit our website. If you have specific questions, feel free to send me an email. Thank you.